These videos are for March 6th, March 9th. We're going to start by looking at solving rational equations. Spent a lot of time on this last class, and I gave students about 30 minutes each class to work on their homework and ask more questions about solving these rational equations. So I'm going to go through this first one, and then we will look at the graphs of rational equations. So here we want to solve this equation. I'm gonna do this quickly because there's a video already on this, but I'm just going to simulate what we did in class. So we said that this equation could be, if we want to write this as 1 over 1 n minus 2 n minus 1 plus 3, and then we have a quadratic here. That quadratic would factor as n plus 4 n minus 1. And if we want to solve it the same way we've been solving it, then we can find a common denominator among our three fractions. If we think about it, here we have n plus 4 n minus 1. Here we already have n minus 1, so it needs n plus 4. Here we only have 1, so we just need both. We need both of these. And so our common denominator here, if we want to do this from the start, would be n plus 4 n minus 1, which means here n cannot equal 1. And here n cannot equal negative 4. So that will determine if we have extraneous solutions or not. Now what we can do is multiply each thing by n plus 4 n minus 1 and solve from there. I'm going to do that in let's do that in red. So I'm going to go ahead and multiply everything by n plus 4 n minus 1 times 1 over 1. That's equal to multiply this fraction by n plus 4 n minus 1 and same thing here, multiply this by n plus 4 n minus 1. Now, hopefully, if we did this correct, if we did our job, we figured out the common denominator from the start, then all of our denominators should disappear. Here, we don't have anything that can divide out, so we're left with n plus 4 n minus 1. Here, n minus 1s go away, and so we're left with n plus 4 n minus 2. And here, all of them go away, n plus 4, n plus 4. n minus 1, n minus 1. So we have plus 3. So if we find a common denominator initially, we multiply everything by that common denominator, which we did in red, then hopefully all of our denominators go away. Now we have an equation we know how to solve. I'm going to FOIL these really quick and then give you the solution and let you check that. So we can FOIL both of these binomials. If you don't FOIL, you're not going to get the problem right. So please make sure that you FOIL. So n squared minus n plus 4n minus 4 equals n squared minus 2n plus 4n minus 8 plus 3. Combine your like terms, get n alone, and what you should end up with is n equals negative 1. From here, you should end up with n equals negative 1. I'm going to let you try that on your own. And this is a solution. If it were positive 1, it would not be a solution. But since it's negative 1, it is a solution, and we're okay with that solution. All right. If you have questions about solving, please come to tutoring. Please ask me questions through the Remind app, email, all of those things. If you were here in class, you had time to work on that. You might not have had all your questions answered, but at least you had time to solve some problems. If you still have questions, please ask me. Now I'm going to go ahead and flip to the back of the back of the first page and look at graphs. Yeah, some of that bled through. That's all right. So we have this function. Excuse me. We have this function here, and we want to figure out some key features of the graph. You know what? Actually, I'm going to stop the video here because this is going to take a little bit of time to talk about what's happening here. But it gives you a good intro in terms of here's our function, here's what a graph of a rational looks like. I'm also going to flip to the back side. Rational functions could also look like this. This is the graph of this function, g of x. here, this is the function, the graph of this function, h of x. So we have a lot of different ways that our functions could look, and we're going to determine how we can figure out how exactly do they look, how can we graph them, what do they look like, all those things. So tune into the second video. Man, can't talk. To see how we can graph these and what's happening between the graph and the function here.